Hello students, in this video I will explain the differentiability of the function and you know the definition of the derivative of the function. Suppose f is a real function and c is a point in its domain. The derivative of f at c is defined by limit h tends to 0 f of c plus h minus f of c divided by h. Here the function is differentiable at x equal to c means this limit exists, that is limit h tends to 0 f of c plus h minus f of c divided by h exists. This limit exists means left hand limit and right hand limit, both of them are equal. And if this limit does not exist, we say that f is not differentiable at x equal to c. And we say that the function f is differentiable at a point c, that is in its domain, if both limit h tends to 0 plus f of c plus h minus f of c divided by h and limit h tends to 0 minus f of c plus h minus f of c divided by h exist, and both of them are finite. And to be differentiable in an interval a comma b, if it is differentiable at every point of a and b, that is for all the points in this interval a comma b, function is differentiable. And the endpoints a and b, that is as in the case of continuity, at the endpoints a and b we take the right hand limit and the left hand limit, that is we take the right hand limit at a and left hand limit at b. That is right hand limit is called right hand derivative, that is which are nothing but the right hand derivative at a and left hand derivative of the function at b, that is at a and b respectively. And this is the meaning of the function is differentiable in a closed interval a comma b. And similarly, a function is said to be differentiable in an open interval a comma b if it is differentiable at every point in the interval a comma b. And the function defined by f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Whenever this limit exists, and it is defined to be the derivative of f, and it is denoted by f dash of x. Here there is one important question. The question will be like this: prove that if the function f is differentiable at a point c, then it is also continuous at that point. But the converse need not be true. That is, if the function is differentiable, then it is continuous. But if the function is continuous, then it need not be differentiable. And given is f is differentiable at point c, then limit x tends to c f of x minus f of c divided by x minus c is equal to f dash of c. Function is differentiable means this limit exists and it is equal to f dash of c. And consider f of x minus f of c and multiply and divide by x minus c. We will have f of x minus f of c divided by x minus c into x minus c. Multiply by x minus c to this and divide this whenever x is not equal to c or x minus c is not equal to 0. And this multiplication and division can be done only when this condition is fulfilled, that is x minus c is not equal to 0. Then taking limit as x tends to c, we will have limit x tends to c f of x minus f of c, that is for the left hand, if you take the limit x tends to c f of x minus f of c is equal to limit x tends to c, right hand side is f of x minus f of c divided by x minus c into x minus c as it is, that is just taking the limit to this expression. as x tends to c. And you know that limit of the difference is difference of the limit. Limit of the product is product of the limits. And if you apply that rule of limit here, limit x tends to c f of x minus limit x tends to c f of c is equal to limit x tends to c f of x minus f of c divided by x minus c into limit x tends to c x minus c. And the next step is that is equal to limit x tends to c f of x minus limit x tending to c f of c is equal to f dash of c. See this, limit x tends to c f of x minus f of c divided by x minus c is called f dash of c. And what is the limit of this? As x tends to c, it is c minus c, which is equal to 0. And next step is limit x tends to c f of x minus limit x tends to c f of c is equal to 0. That is, what is limit x tends to c f of c, that is equal to f of c. Limit x tends to c f of x minus f of c is equal to 0, or limit x tends to c f of x is equal to f of x, and hence f of x is continuous at x equal to c. And to show that if the function is continuous, then it need not be differentiable. Let us take one suitable example, that is f of x equal to mod x. And it is a continuous function. You already know that f of x equal to mod x is a continuous function. And consider left hand derivative at x equal to 0, that is L f dash of 0. That's equal to limit h tends to 0 minus, what is f dash of 0? F of 0 plus h minus f of 0 divided by h. And that is equal to, what is f of 0 plus h? That is f of h. Here, as h tends to 0 minus means h is negative. When h is negative, what is f of x? Mod h. When h is negative, what is modulus of h? Minus h. And that's why f of 0 plus h is equal to minus h minus 0 divided by h. And h gets cancelled. Limit h tends to 0, minus 1. And that's equal to minus 1. Now let us find rf dash of 0. And rf dash of 0 is equal to same limit h tends to 0 plus f of 0 plus h minus f of 0 divided by h. That's equal to limit h tends to 0 plus, what is f of h? F of h is equal to h only, because h is tending to 0 plus means h is positive. And h minus 0 divided by h, and that's equal to h by h. H gets cancelled here. Limit h tends to 0 plus 1, and that's equal to 1. Here you can observe that rf dash of 0 is not equal to lf dash of 0. That is, left hand derivative and right hand derivatives are not equal. Therefore, f of x is not differentiable at x equal to 0. And with this much, I'll conclude this video. In the next video, just I'll recall the important derivatives that you studied and the rules of derivative which you studied in first year. Thank you.